Hello and welcome to our lesson 3.6, Ratios and Proportions. Go ahead and put today's date, and by the end of this lesson what we hope to be able to do is that I can construct ratios and proportions and solve for a missing value of a proportion. Now, to start out with, we just have a couple of vocab words. Our first one is ratio, and ratio is a comparison of two numbers by division. Ratio is a comparison of numbers by division. Now, there's a couple of different ways we can see ratios be written. The first way is with division, which means we'll use a fraction bar, like comparing 1 out of 3 people, so 1 to 3, 1 over 3. Or another way, you can see it written as like 1, and then your colon 3, or the words actual 1, 2, 3. Okay? And one big thing we always want to make sure with ratios is if you notice 1 over 3, 1 can't be divided by 3 evenly. So this is its simplest form. So we always want our ratios to be in simplest form. So we're going to simplify our ratios. Now once we have a ratio, or even once we have a couple of ratios, we can set up a proportion. And proportion is an equation with two ratios that are set equal to each other. And proportions we solve by using our cross products. Now remember, the word products means to multiply, so we solve by cross multiplying. So cross products is just another way to say cross multiply. An example of a proportion would be like if I had one fraction, I'll go back to my 1 over 3, and I say it's the same thing as 4 over 12. So if you notice, proportions have two ratios, 1, 2, and they're separated by an equal sign. All right, our next definition is rate, and rate is a ratio using two different measurements. And a good example of that would just be like whenever you think about your car, like miles per hour, like we're driving 35 miles per hour, because that means we're comparing miles to the hours it takes to drive those miles. And our last one is scale. Scale uses rates or ratios that are used for models and drawings and maps. And scales are really important for maps, especially when you think about the distance on a map might be that 1 inch equals 1 mile. So we have to set up a scale for that of inches to the miles. Now let's look at some examples. So example 1, we're asked to determine whether 4/5 and 24 over 30 is a proportion. So we have 4/5 and 24 over 30. Now there's two ways to do this. There's two different methods. So I'm going to show you both methods. So method 1, we just go back and we look at both of these fractions separately. And we say, what does that fraction bar in 4/5 tell us to do? It tells us to divide. So if we do 4 divided by 5, we get 0.8. Same way here. If we take that fraction bar and say 24 divided by 30, we get 0.8. So when we divide them both, they give us the same answer. So they are equal to each other. So yes, these are proportional. Now, a second way to do the same problem, so method 2, is to take these two separate ratios, 4/5 and 24 over 30, and to set them equal to each other, so therefore we can solve it like a proportion and cross multiply. And say 4 times 30 equals, drops down, and then 5 times 24. So 4 times 30 is 120. 5 times 24 is 120. So 120 equals 120, so yes, they are proportional. And if you look at both of these, as long as they equal the same thing, whether you do the division or cross products, as long as they equal the same thing, it's yes, they are a proportion. So method 2 is using our cross products. Okay. Now, let's go on to example 2. Our second example says to use cross products. That means we have to use our second method we saw to solve out this second example. So 0.4 over 0.8. Remember, you have to set them equal to do a cross product. Equals 0.7 over 1.4. So we set up a proportion. Remember, proportion means two ratios are set equal. So you gotta have an equal sign between them. Alright, and now we just cross multiply. So 0.4 times 1.4. 0.4 times 1.4. Drop down our equal sign, and we do the next one. 0.8 times 0.7. Okay, now we're just going to multiply. 0.4 times 1.4 gives us 0.44. Okay, and then we have 0.8 times 0.7, which gives us 0.56. So if we look at these two proportions, 0.44 does not equal 0.56, so they're different. So they're not equal, and no, it's not a proportion. So if we compare this example with our last one, if it equals the same thing on both sides, it's yes, it is proportion. If it doesn't equal the same thing, then it's no, not a proportion. Now, our next example actually wants us to solve a proportion for a certain variable. So example 3 gives us n over 15 equals 24 over 16. So they already have it set up like a proportion for us. All we have to do is cross multiply and say n times 16 equals, and then 15 times 24 okay. N times 16 is 16n. Remember, number always goes in front to make it the coefficient. And then 15 times 24 gives us 360. Now, because it's an equation, we just now isolate our variable the same way we would in our past. So 16 and n are side by side, meaning they're being multiplied. Opposite is to divide both sides by my coefficient of 16 to isolate my variable n. So my 16's cancel, n is by himself now, which is what I want. And 360 divided by 16 is 22.5. Now we can do a quick check to make sure our proportion is correct. Remember, you always want to go back to the way it looks in the original before we did anything to it. The way it looks way up here. So n over 15 equals 24 over 16. Now we say n is 22.5, so 22.5 over 15 equals, once again, our 24 over 16 just drops down. Now, remember, there's two ways you can do this check. You can either divide them out or cross multiply them. So I'm just going to divide them. Say 22.5 divided by 15 gives me 1.5 equals 24 divided by 16 also gives us 1.5. So 22.5 right here makes these two ratios proportional, so we check. Let's do one more example. Example 4. We have 7 over 3 equals x over 21. So first thing we need to do is cross multiply because we have our proportion all set up. So 7 times 21 equals 3 times x. And then we say 7 times 21 gives us 147 equals 3x. Now, we're still solving for a variable, so we're trying to find what x is. So we look at x, he's on the right side with our 3. They're side by side, so that means being multiplied. So the opposite is to divide both sides by 3. Our 3's cancel out, and we're left with x on the right. 147 divided by 3 gives us 49. Once again, let's do a quick check to make sure we did it correctly and got the correct answer. So 7 over 3 equals x over 21. 7 over 3 equals x, we said was 49 over 21. Now we just divide. So 7 divided by 3 is 2.3 repeating equals 49 divided by 21 is also 2.3 repeating. So we're good. We check because both of our sides equal the same. Now for our fifth example, we're going to look at our one that's a application problem. So it says Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, so that means we're going to have ratio with different units. How far can he ride in 6 hours? So first thing, let's go back and write our first rate. So it says Trent goes on a 30-mile, so 30 miles, and the distance is 4 hours. So we know we're comparing his miles and his hours. And I always like to set up the units first, that way I know what I'm comparing. And we said he went 30 miles in 4 hours equals. And it says at this rate, how far can he ride in 6 hours? So let's come back over here to where we have our problem set up and say hours. Should my 6 go on the top with my miles, or should it go on the bottom with my hours? And it should go on the bottom. Now it says how far, so I don't know the distance in miles, how far it's going to be. So I have to put my variable x for what I don't know. Now I have my proportion set up. my rate 30 miles for 4 hours. I don't know my distance for 6 hours. Now that we have a proportion, we just cross multiply. 30 times 6 equals 4 times x. 30 times 6 is 180 equals 4 times x is 4x. We're trying to isolate x and get him by himself, so we're going to divide both sides by 4. 4's cancel, and 180 divided by 4 gives us 25 equals x. And we need to take this one step farther because it's a word problem and it says at this rate how far. So we go back up here and we look, x was solving for miles. So that's 25 miles he can go in the 6 hours. Okay. And that finishes us up. Thank you very much, and we'll review in our review of proportions. You all have a good evening.